Good morning. Today we're going to look at the triangle midsegment theorem. First we got to make sure we understand what a triangle midsegment is. So the triangle midsegment, the midsegment of a triangle is the segment that joins two midpoints. So right here I recognize that D, since AD here and BD are both congruent, that means D is the midpoint. And similarly, on the other side, BF and CF are congruent, therefore F is the midpoint, and that clearly makes segment DF a midsegment. So this is what we're looking for. We're looking for this segment right here. It's called the midsegment. The midsegment theorem is really how we're going to apply this. The midsegment theorem has two properties. The midsegment is going to be parallel to the base. DF is going to be parallel to AC. And it's going to be half the measure of the base. So in this case, looking at this triangle, we can see that DF here is going to be parallel to AC, and we can see that DF is going to be half the measure of AC, half the measure. Now, how does being parallel to the base help me? Let's look at this situation for a moment. First, I recognize that G, H, and I are all midpoints. G, H, and I are all midpoints of triangle ABC. Therefore, I recognize that IG here and IH here and GH here are all midsegments. So because of that, I end up with lots of parallel lines. Let's see, IG here is going to be parallel to AB. Also, IH here is going to be parallel to AC, and finally you can see that GH, the more obvious one, is going to be parallel to CB. So there are three bases. You have to make sure there's three sides, and all three sides of those could be a base. Now, how does that actually help me? Let's take a minute to look. Here we are with our same triangle, and I've already recognized which ones are midpoints. I'm trying to find angle X, or find X right there, angle GIH. I'm going to start with GI, recognize that GI here and AB here are parallel, and in reality that's giving me two parallel lines and a transversal. Do you remember two parallel lines and a transversal? Which clearly tells me I have two corresponding angles. This angle B, the corner, is 61, corresponds to this angle, which is also 61, corresponding angles. Similarly, because IH is also a midsegment, then it's parallel here, which turns out to be that CB is now my transversal. Do you see the two parallel lines and the transversal? So once again, you have another set of corresponding angles. That makes this 40 correspond to this angle. And now if you'll zoom in to this spot right here, paying attention right here, you recognize that these all together have to equal 180 degrees. So I can say that 61 plus X plus 40 has to equal 180 degrees. Of course, that gives me X plus 101 equals 180. And subtracting, I get that X equals 79 degrees. Now let's talk about how the second property, half the base, helps me. Here I've got two triangles, and both with a midsegment, and I think pretty clearly you'll see how they show up. If Y is the midsegment here, then it must be half of the base. So I can say Y equals half of 36, which makes a easy equation to solve. I know that Y is 18. Similarly, on this side, if I recognize that DE is the midsegment, then I know that DE is going to be half of BC. Substituting in, I know that 9 is going to be half of BC, and multiplying both sides by 2, I get that BC is 18. Now, a more typical problem might look like this. And here's where we're going to use half the base in two different ways. All right, we'll start off with the way we talked about. We know that if AB is the midsegment, then AB must be half of XC. That makes sense. The midsegment is half of the base. So I'm just going to substitute in now, and I know that 3x minus 1, the value of AB, would have to equal half of 34, the value of XZ, and I've got my algebra from there on out. And I find that x equals 6. However, there is another way of thinking about this problem. If AB is half of XZ, then isn't XZ twice AB? Sometimes this is a more useful way of thinking about the midsegment. In this situation, if XZ is twice AB, then I can plug in and say that 34 equals twice 3x minus 1. Similarly, with algebra and the distributive property, you can see that you'll end up with the same situation, same solution. However, oftentimes using this doubling will get rid of fractions that we're not used to.